In this video, we are going to go over multiple different types of functions, talk about their names, their shape, and some of their key characteristics. So this first function, f of x equals x, is a linear function. And a linear function is a line, and the basic linear function will be an increasing function. So a linear function with a positive slope will always be increasing and it'll never decrease. Then the domain and range will be negative infinity to infinity because it's going to get longer and longer in both directions forever. Linear functions have a slope of 1 over 1. So if this is 1, this is 1. And so if we talked about f of 4, we know that the y would be 4, assuming that the slope is 1. The next function we're going to talk about is a quadratic function. And a basic quadratic function is a u with its vertex at 0, 0. It is going to have parts that are increasing and decreasing. If it's an upward facing parabola, the first section will decrease and the second section will increase. The domain will also be negative infinity to infinity because it is going to get wider and wider and wider. The range will depend on where the vertex is. Since the vertex here is at 0, it's 0 to infinity. Now, if my function equals 36, that means x squared would equal 36. So that means x would equal plus or minus 6. The next function we're going to talk about is absolute value. And the shape of this graph is like a parabola, but it's a V, and the basic function starts at 0, 0. So similar to a parabola or a quadratic function, it's going to decrease from negative infinity to 0 and then increase from 0 to infinity. Its domain will also be the same as a quadratic function, and the range will also be similar because they are the similar shape, just slightly different pattern when graphing. It wants to know when the function increasing at x equals negative 25. Well, x equals negative 25 would be somewhere over here. And the negative part of an absolute value facing up would be decreasing, so this would be false. The next function we have is a square root function. A square root function only goes one direction, and it's going to start at 0, 0 for the parent function. A square root that is pointing in the positive direction will only increase. It will never decrease. And its domain and range are always going to be based on the starting point. So in this case, the starting point is 0, 0. So my domain and range will each start at 0 and go to infinity. Now f of 9, well, if f of 9 would equal the square root of 9, that means f of 9 would equal 3. The last function we're going to talk about is a cubic function. A cubic function is going to have kind of a curvature shape. It's going to be an always increasing function. If it was negative x squared, it would have a decreasing part, but if it's a positive x cubed, it will always be increasing. And its domain and range will also be negative infinity to infinity because kind of like a linear, it's going to get wider and wider in all directions. If the function is equal to 64, basically I'm trying to find the cube of 64, which would be 4, cubed root of 64. On the back, the first function is f of x equals 1 over x. This is a rational function. A rational function is going to have asymptotes based on the denominator. In this case, my asymptotes are going to be at the zeros. And we're going to have a part of our rational function in quadrant 1 and a part of our rational function in quadrant 3. So in this case, if I'm reading my graph from left to right, it's going to decrease in this quadrant 3 and also decrease in quadrant 1. So it's going to decrease from negative infinity to 0, and then again from 0 to infinity. We exclude 0 because that's where the asymptotes are. it will never increase, this parent function. Similarly, our domain and range will be similar to our decreasing. It's going to be from negative infinity to 0, union 0 to infinity. Same with the range because of the asymptotes. That 0 will be different depending on where the asymptotes are. If I'm doing 1 over, or f of 1 over 10, that means I'd be doing 1 over 10, right? Because that's what I would plug in for x. So then it'd be 1 times 10 over 1, which would give me 10. Number 7 is an exponential function. This is also going to have an asymptote, but at 0. And it's be kind of like a plane taking off where it starts off low, or a rocket ship. So it's an always increasing function, never decreasing. The domain is going to keep getting wider and wider, so it'll be negative infinity to infinity. And it's approaching 0, but it'll never touch 0 because of that asymptote. So my range will be 0 to infinity. But again, the 0 is going to have that round bracket because it will never touch 0. It's just going to get smaller and smaller and smaller and smaller towards 0. So true or false, the graph of f of x equals e to the x has an asymptote at x equals 0. This is false. It has an asymptote at y equals 0. The next function, this is a logarithmic function, and specifically a natural log function. The natural log and exponential are opposites of each other, so my asymptote is going to be along the y-axis in this case, and my function is going to look something like this. Notice it's kind of like the mirror image of the exponential. So since my asymptote is at 0 for the x, it's going to increase from 0 to infinity. It's never going to decrease. My domain again starts at 0, so 0 to infinity, but it's not touching 0, so we're going to have that round bracket. My range, it's going to go down and up forever, so negative infinity to infinity. And the question here says the equation of the asymptote on the graph, f of x equals ln of x, is, so where's the asymptote? The asymptote is at x equals 0. The last function we're going to talk about is a greatest integer function. So sometimes we call a greatest integer a step function because it's going to look like steps. So we're going to have a closed circle and then an open circle. Closed circle, open circle, closed circle, open circle, closed circle, open circle. And this will continue on. It'll always be closed on the left, open on the right. And this is because it accepts all real numbers as the input, but then it outputs the greatest integer less than or equal to the output. So I'll kind of give you some examples of that. So 2.9. 2.9, the greatest integer of 2.9 would be 2, not 3. That's why there's an open circle on 3. So if we look closely at this graph, 2.9 would be about here. Well, it's equal to, that's 1.9, sorry. 2.9 would be about here. So it's equal to 2 because that's what's on that bar. When it gets to 3, then it goes up to there. But 2.9, you'll always return less than that value. So negative 1.02, what's the closest integer less than negative 1.02 is actually negative 2. So remember, negatives go the opposite way as positives. So be careful with that. 1 will return 1. 8/3, well, that's like 2 and 2/3. So again, we have to go down, so to 2. So my domain is going to be all real numbers, or negative infinity to infinity. The range is, we'll call it the set of all integers, because it's not going to be it's not negative infinity to infinity because that would include all the decimals and fractions in between. We're only looking for integers. Remember, an integer is a positive or negative whole number.